Okay guys, so today we're going to solve the problem count BST nodes that lie within a given range. So what the problem says is that given a binary tree and a range LH inclusive, count the number of nodes in the BST that lies in the given range. The value smaller than the root, go to the left side, and the value is greater than and equal to the root, go to the right side. Okay, so what the question says is that we're given two values, L and H, and we need to find how many values are present between L and H inclusive of L and H. Okay, so let's suppose over here in this question we're given 5 and 45. So we need to find how many values are present between 5 and 45. So let's count. So is 10 present? Yes. Is 5? Yes, because it's given inclusive, so 5 is also present. And okay, is 50? Then no. And is 40? Then yes. Okay, so and then we just increment the counter, so we will just get 3. Okay, and similarly for this question it's given 2 and 8, and if we see 5 is inclusive, 4 is there, 3 is also there, 6 is also present, 7 is also present. So all the elements, so all the nodes are in between, so all the nodes lie between 2 and 8. Okay, so how we're going to solve this problem is it's pretty straightforward. We're just going to loop through, we're just going to recursively go through the leftmost node, and as we go through them we'll just check if the data of this node is less than L and is greater than H, and if it is, we'll increment the counter and we'll just go through the left side and then the right side. Okay, so let's solve the problem. So let's create a count function, not a count, so we'll create a count. We'll pass it as a list so we can update the list and just return it. Then check, this is going to be the function that will create, have a root, we'll pass the count, pass low, and we'll pass high. Okay, and in the end we'll just return root count of 0. Okay, now what we need to do is we need to create def check CK, yeah, and we need to pass root low, root count low and high, low and high. Okay, now first we'll check, we'll do the base case, we'll check if root is not present, we'll just return. Okay, and now we'll check if the root dot data is greater than or equal to low and root dot data is less than or equal to high. Okay, less than or equal to high, then we'll just increment the count of 0 plus equal 1, and yeah, and then we'll just go through the left side of the tree and then the right side. So left will be root dot left count low and high, and check root dot right count low and high. Okay, and yeah, this is pretty much it. So let's run the code. And submitting it. Yeah, it's submitted, guys. So let's walk through the code one more time. So let's suppose we're given this question, okay, and 5 and 10, 5 and 45. Okay, so we're creating a count list over here, which will have 0 as a value, and we'll just update that 0, and we'll just return that 0 in the end, the value present at the 0th index in the end. Okay, so now we're going to pass the root. So the root is 10, we're going to pass 10, so let's write it here as well. So the root is 10, okay, on passing 10, and the count of 0 is 0. Okay, now when we pass root, we'll check if it is not root, it is, we'll check if root dot data is greater than or equal to low. So it is greater than 5, and is it less than or equal to 45? Yes. Then we'll just update this to 1, and then we'll go to the left of the root. Okay, now we go to the left, which is 5. Now we check for 5. Now we check for 5. Now we see if it is greater than or equal to low and less than or equal to high. We increment the counter. So it will become 2. This time it's going to be 5. Okay, now we go to the left of 5, which is 1. Okay, now the root is 1. Now we check for it. Then it isn't less than, greater than or equal to low, or less than or equal to high. So we just go to the left of 1, and if we get not null, we'll return. Okay, now we return to 5. We go to 1. Actually, return to 1. We check for right. We get a null. We return. Then we go to 5. We check for its right value. That is also null. So we return. We go to 10. We check for its right value, which is 50. So is 50, less than or equal to 5, greater than or equal to 5, and less than or equal to 45. So it's not, great. It's actually less than. It's actually greater than 45. So we won't go inside. We won't increment the count, and we'll go to 40, the left of 50. So this time it will be 50. This time it will be 40. Now we go to 40. We see that it is greater than 5 and less than or equal to 45. Then we increment the counter to 3, and then we just go to 100. Then we go to its left, which will be null. 40 is right, left, which will be null, and we return. We go to 40 is right, which will be null. We'll return. Then we return to 50. Then we go to 50 is right. We check for 100. If it's left and right is null, and it isn't, so we just return. And so all the nodes are processed only once in this case. So the time complexity is O of n, and we go through, and the space complexity will be O of h, because the stack frame that will be built will be exactly as the height of the tree. So yeah guys, that's how you solve the problem. And if you like the video, please do like, share and subscribe, and I'll see you guys in the next video. Thanks.